is Chapter 3, Linear Functions, Lesson 3.1, Graphing Lines and Equations. And you can follow along with me in your textbook on page 155. The concepts we're going to talk about today are linear equations. Linear equations form a line when you graph them, straight line, no curves. And we're going to talk about standard form. Standard form comes looking like ax plus by equals c. An example of that would be 3x plus 2y equals 5. Notice there's a number 3 here would be a, 2 would be b, and 5 would be c. A constant is a number without a variable. In this case, c is a constant. It would be the number 5 in the example equation. Let's talk about how to identify linear equations. On page 55, you can see that there will never be exponents on the y or the x. There's no x squareds or x to the thirds or x to the fourths. There's no y squareds or y to the thirds or y to the fourth. Just plain old x and plain old y. And x and y will be separate. You won't see x times y. You won't see them stuck together. If we want to tell if something is a linear equation, we can test it by rewriting it in standard form. If you look at page 159, numbers 13 through 18, these are examples or problems that you would do this way. Number 13 and 16, we can automatically say, no, these are not linear because of the y squared. Number 15, we can say no because of the xy together, x times y. So we don't even have to try to rearrange those. But look at number 14. We have 8 plus y equals 4x. And I'm going to rearrange this. I'm just going to do some algebra here. I'm subtracting 8, and then I'm subtracting 4x. And I end up with this, negative 4x plus y equals negative 8. So a is negative 4, b is negative 1, and c is negative 8. So yes, this is linear. This is in standard form. Plain old x and plain old y. Number 18 looks like this. Y equals 4x plus x. I'm going to combine like terms and get y equals 5x. And then if I really want to put this in standard form, I'm going to subtract the 5x to get negative 5x plus y equals 0. So a is negative 5, b is 1, and c is 0. This is standard form, so yes, this is linear. All right, what if we want to find intercepts from a graph? What are intercepts? The x-intercept is where the line crosses the x-axis. So you can see my little example here. An example might be at the point 3 and 0. So notice that we're crossing where x equals 3 and y equals 0. So the line is just crossing the x-axis. The y-intercept is where the line crosses the y-axis. So in my little example here, maybe it's at the point 0 and negative 3. So y is negative 3 and x is 0. So they're just crossing points. So just right where you cross over the x line is the x-intercept, somewhere along here, and where you cross the y line is the y-intercept, somewhere up and down here. So look at page 159, numbers 19 and 20. If I want to tell what the x-intercept is, I'm going to look at where it crosses the x line, and that happens to be at 1, 2, 3. So that point is 3, and notice that y, we don't go up or down, so it's going to be 0. So the x-intercept of this line is 3 and 0. The y-intercept is where it crosses the y-axis, and that is at where x is 0, because we didn't go left or right, and then we're going to go up 1, 2, 3, 4, and so the point is 0 and 4 where the y-intercept is. That's how you read that off a graph. If you're looking at a table, you're going to look for where you see zeros. So notice here we see the x-intercept at negative 2 and 0, and I know that's the x-intercept because x has a number and y is 0, because y, we wouldn't go up or down, but we would cross x at some number. You can have 0 and 0, obviously that's the origin, but often you just have a number for x. The y-intercept is going to be here where x is 0 and y is 2. And we can just look for those right in the table. We can graph by using intercepts. So we can find the intercepts from an equation by plugging in zeros. That's a funny thing we say when we're going to substitute in a number of some kind for a variable. This is a good way to find the coordinates of 2 points, and that's a good way to graph a line. Look at page 160, number 23 to 28. In number 23, I particularly picked a couple of these. I have y equals 4 plus 2x, and if I want to know what is y when x is 0, I can plug in the 0 for x right there. And so I'm going to solve this. I get y equals 4 plus 0, which is y equals 4. And there is not only my y-intercept, but it's 1 point on our graph, and we only need 2 points to draw a line. So let's find the x-intercept. We'll say, what is x when y is 0? So we're going to plug in 0 for y this time instead. 0 equals 4 plus 2x. So I'm subtracting 4 and dividing by 2, and I'm ending up with x equals -2. So here's another point on our graph. This is the x-intercept. So I'm ready to graph. I can just plot these points. I have -2 and 0, that was the x-intercept, and I have 0 and 4, that's the y-intercept. I connect these 2 points, and I have a straight line. The 2 points are one where we cross the x-axis and one where we cross the y-axis, and we connect them to draw a line. We can also graph, so that's one way to graph. We can find the intercepts. We can also graph by making a table. So we can make a table of values using whatever numbers we want to. This really bothers some people, but there are infinitely many choices. Some of them are not very wise. For example, if you choose 10,000 for one of your numbers, your graph is going to be kind of large, or your scale is going to be kind of really compressed. But look at page 160, numbers 31 to 34. We're going to look at number 34 here. I have x equals 10 minus y, and I want to make a table. So I set up a table with x and y, and then I have to just start making some choices. I'm going to have to make up some numbers that I want to plug in for x. Typically, I choose 0 or 1 because they're easy. In this case, I started with -1 just for kicks, and I plugged that in here. And what I ended up with after I solved this, subtracting 10 from both sides, get a -11 equals -y, and then we didn't want -y, so we had to deal with that, and we end up with 11 equals y. Well, that's even pretty big for my simple little graphs. So I tried to aim for a number that might give me a little bit smaller y, so I tried a 5. And so I plug that in here, and I get y equals 5. So 5 and 5 is also a point on my graph. And then just for kicks, I did another one. I plugged in 7, and I got 3, y equals 3. So here's a tip. You only actually need 2 pairs. So you only need 2 x's to solve for the y's that go with them. 0 and 1 are good choices because they're easy. Here I chose other numbers because they were kind of for some reason I was getting really large y's to go with my x's, and they weren't going to fit on my graph. Okay, so that first point doesn't even fit on my graph. It's way up there in my work somewhere. But if I plot the point 5 and 5 and the point 7 and 3, then I can connect those 2 points and get the line that I'm looking for. All right, numbers 29 and 30 are special. So let's talk about graphing horizontal and vertical lines. X equals a number, so I'm going to make up one. What if it was x equals 5, or x equals 10, or x equals a -50? All of these are going to be vertical lines, and x is always that number, and when x is always that number, I like to think about it just slashing through x, and so it's up and down, straight up and down, straight through where x is that number. In number 29, we have x equals -2, and so y is basically everything in the world, and x is always going to be -2, so it's just going to stack up straight up and down. I kind of do this in my mind, drawing up and down, going, okay, x is -2, and y is everything, and that gives me a very straight up and down number, or line, not a number. On number 30, we have y equals -4, and notice that x is everything in the world, y is always -4, and so that slashes straight across through y equals -4, and we're going to end up with all those x numbers lined up sideways, but the y number is always straight across -4. So, what did we learn? Linear equations make lines. Linear equations don't have exponents on the variables. They just have a simple x and a simple y, and they can be written in standard form. Standard form is ax plus by equals c. An x-intercept is where the line crosses the x-axis. At that point, y is always going to be 0. And a y-intercept is where the line crosses the y-axis. And at that point, x is always going to be 0. Do you know what the intercepts of a graph mean? Let's look at page 160, number 21, just for the meaning. So we have this graph, and it's called the descent of an eagle, and the y-axis represents height in feet, and the x-axis represents time in seconds. And if you notice, the y-intercept is at 0 and 20 right here, and that means that our eagle at 0 time, at the beginning, was at 20 feet in the air. And then notice the line coming down. This is the descent of an eagle, and at 6 seconds, and the eagle is at 0 height. So the x-intercept here means that it took 6 seconds for the eagle to get down to the ground. All right, now I want you to go to the Alex homework. It is labeled Lesson 3-1, November 2, and there are 9 problems. And November 2, and there are 9 problems that I want you to do right now. Remember that you can rework them as many times as you want to get them right, so please get 100%. I'm going to make a separate video of those examples in case you have any trouble, but go ahead and try them all by yourself and see where your understanding